Hi there. If you've not seen it, then check out the video on the equations of motion. In it, I go over how to derive the equations as well as some important points to remember when using them. In this video, I'll go over 3 typical questions involving the equations of motion. When a new question is displayed, you might want to pause the video and try the question yourself before taking a look at the answer. Let's get started. Okay, this question says, a car accelerates uniformly from 13 meters per second to 31 meters per second while entering the motorway, covering a distance of 220 meters. Part A then asks, calculate the acceleration of the car. So, where we might want to start is to write down what we know. We know, of course, that displacement is 220 meters. We know initial velocity 13 meters per second, final velocity 31 meters per second. Acceleration, of course, that's an unknown. And we don't know the time it takes in order for the car to accelerate. Now, one thing is that all of these can be taken as positive. The car isn't changing direction, so we don't need to take, say, one of the velocities as positive and one is negative. So these are all taken as positive. I'll write down the equation which I would use in order to work this out, and that's v squared is equal to u squared plus 2as. Now, of course, I can't use, at least not at this point, v is equal to u plus at because a is not known and t isn't known. Can't use the second equation, s is ut plus half at squared, for the same reason. I don't know a or t. And the last equation, s is half u plus v times t, doesn't have an a in it. So, of course, I can't work out acceleration there. Now, if I put in the numbers, so if I do the substitution, v 31 squared is equal to 13 squared plus 2 times our unknown a times 220. Let's see, I'll get the calculator and work out some of these values. So 31 squared is equal to 961. Now, if you're working out these, you might want to do this in a slightly different way. You might be rearranging in order to find a as the subject of the equation, but I'm making this fairly simple. 13 squared is 169 plus, well, 2 times 220 is 440 times a is, of course, 440 a. Now at this stage, what I'll do is I'll rearrange the equation. So I'll switch to the left and the right hand side. I'll also take 169 away from both sides, and that gives me 440 a is equal to 961 minus 169 is equal to 961 minus 169, 782. And of course, at this point, what I want to do is divide both sides by 440, and that'll give me a. So a is equal to 782 divided by 440, and that gives me this, 1.8 ms to the minus 2. Part B, actually I'll move the paper up at this point. So part B, it's asking to calculate the time taken for the car to accelerate. And I'm going to use this equation, v is equal to u plus at, and then if I substitute, I have 31 is equal to 13 plus 1.8 t, and of course a is the value I've just worked out for the acceleration. Then what I'll do is, again, I'll switch the left and the right hand side and also subtract 13 from both sides, and that'll give me 1.8 t is equal to 31 minus 13, that's 18. And last but not least, again, move the paper up slightly, I have, by dividing each side by 1.8, I have t is equal to 18 divided by 1.8 is equal to, I'm not going to do that in the calculator, 10 seconds. Question number 2 says, a trolley runs down a track from rest before passing through a computer timer displaying its speed as 2.77 meters per second. The distance travelled by the trolley during this time was 1.20 metres. Part A then asks, calculate the acceleration of the trolley. So again, we'll write down what we know, that S is 1.20 metres. Now we're not told this directly in the question, but since it says that the trolley runs down a track from rest, obviously initial velocity is 0 metres per second. Final velocity, well, we're told that that's 2.77. Acceleration, that's what we want to find out. We don't know that, and again we don't know time. Now this is the equation again that I would use in part A of this question. V squared is u squared plus 2as, and then if we insert a number, so do the substitution, 2.77 squared is equal to u is 0, so of course u squared is also 0, plus 2 times our unknown a multiplied by s, which is 1.2. Then use the calculator to find 2.77 squared. That is 7.6729. We don't want to round that up at this point. We'll talk about rounding later. Is equal to, well, we don't need to worry about the 0. 2 times 1.2 is 2.4, of course. So we've got 2.4 a. And then, of course, to find a, I'll switch the left-hand side with the right-hand side and divide both sides by this 2.4. So, of course, I'll then get, therefore, a is equal to 7.6729 divided by 2.4, and that gives us this. Now, the values we're given in the question are final velocity v, that's 2.77 metres per second, and of course 1.20 metres, which both have 3 significant figures. So of course we want to write this number to 3 significant figures, and that would give us 3.20 ms to the minus 2. For part B of the question, it's saying calculate the time taken for the trolley to travel the distance of 1.20 metres. And I'll use again the same equation as I did in part B before, which is V is equal to U plus AT. Before I substitute, I'll move this paper up again. And do the substitution, so we've got 2.77 is equal to 0 for U plus the value we've just found, 3.20 times T. And of course, to find T, I want to divide both sides by this 3.2. So therefore, T is equal to 2.77 divided by 3.20, and that gives me this number. Now, same rule applies that I want to write this to 3 significant figures. There is the rule that, of course, you are allowed 2 too many figures and 1 too few. So I'll write this as 0.866 would be 3 significant figures, and of course the unit seconds. Question number 3 says, a ball is thrown vertically upwards with an initial velocity of 24.5 metres per second. And then part A asks, calculate the time taken for the ball to reach its maximum height. Now, what I'm going to do is use sign convention. Now, when I say sign convention, it basically means that I'm taking one direction as being positive. This is an object thrown upwards, and of course after it reaches maximum height, it's then going to be changing direction. It's going to be moving downwards. So it would help if at the start of the question I write something like this, taking upwards as positive. So we know that S is what we're trying to find out. Because I'm using upwards as positive and the object is thrown upwards at 24.5 metres per second, that would be plus 24.5 metres per second. At maximum height, the vertical velocity is 0 metres per second. An acceleration when the ball's moving upwards in the positive direction, it's going to be decelerating. That would give us an acceleration of negative 9.8 ms to the minus 2. When it's moving downwards, it is accelerating, but it's accelerating in the negative direction because we're taking it upwards as positive, downwards as negative. So it would be accelerating in the negative direction. So whether it's moving upwards, decelerating in the positive direction, or accelerating in the negative direction, basically, acceleration, if we're taking up as positive, is negative 9.8 ms to the minus 2. And time, we don't know. Now, what I'm going to use in this question is v is equal to u plus at. Substitute gives me, as we said, v was 0, 24.5 plus, in brackets, I'll say negative 9.8 times t. Now what I'm going to do actually is take this negative 9.8t, if I move that to the other side it becomes positive. So I get 9.8t is equal to 24.5. And therefore t is equal to 24.5 divided by 9.8. And let's see. The calculator, 24.5 divided by 9.8 gives me 2.5 seconds. Now, part B. Move this paper up. It's asking, calculate the gain in height of the ball during this time. So in other words, in that 2.5 seconds. So we're going to use this equation. S is equal to ut plus half at squared is equal to u, as we said, is 24.5, that's positive. We just worked out that t is 2.5 seconds plus 0.5 times negative 9.8 times 2.5 squared is equal to, now if we work out each part of this question, so 24.5 times 2.5, work out that term first, 61.25, and plus whatever's in brackets here, so 0.5 times negative 9.8 times 2.5 squared is equal to negative 30.625. So basically 61.25 minus 30.625. And that will give us this. 30.625. Now again, if we look at that question, we're given the initial velocity, 3 significant figures, 24.5. So I actually want this as 3 significant figures. So if I write that down as 30.6 meters, that's us for part B. So there we have it. Hopefully you got the correct answers if you were trying them yourself. And remember, it is possible to get the correct answer for some of the questions by using a different equation of motion. For more information on upcoming videos, summary sheets and so on, visit physics-podcast.co.uk. Thank you for listening.